Okay, good morning. Purpose of this video is to show you how to do a statistics problem, the type of problem that's typically found in a basic statistics course and problems that are testing the normal standard deviation. I mean a normal distribution here. Now, first thing I want to do is I want to go ahead and share my screen and just show you the sort of problem that we're going to be dealing with. All right, so let's take a look at, let's see here. Take a look at the problem. The problem, as we find in the text, deals with the following. The very first paragraph talks about sulfur dioxide in the industry, and it talks about setting off chemical changes in the atmosphere, and it mentions that liquid acidity is measured by pH. And the purpose of this section here, the purpose of this entire section is to really explain to the student what the purpose of the problem is and why it applies to stuff you might see in the news or stuff that affects the environment or something like that. This whole thing here is designed to generate interest in the problem. I think what happens sometimes, though, is students will look at this and they'll see a bunch of numbers and they'll say, wait a second, where does this fit in? Where does this fit in? So the very first tip I will give is to be patient when you read a problem. Lots of times, the author of a problem is trying to get you interested in doing the problem with the idea that if the problem is applicable to the real world, then you'll be more interested in doing it. So that's what the first part in green is about, is to get you interested in the problem. Now we get down to here. It said the pH of rain. Now, by the way, I should explain that. All pH is, it's taught in chemistry classes. If you must know, it's a minus base 10 log of the concentration of the hydronium ion. And basically what it means is that at a certain temperature, and I believe it's 25 Celsius, neutral pH is 7. Anything higher than that is basic. Anything lower than that is considered acidic. And to be acid rain, you're talking about a pH of something less than 5. So the lower the pH, the more acidic. The higher the pH, the more basic. But that's just background. Now let's get to how to actually do the problem. And that is going to be the part in red. Here it says the pH of rain at one location is a normal distribution with a standard deviation of 0.54. So what students can pick up on is that we're going to be using a normal distribution. The mean is 5.43. That's a mu. Whoops, you can't read that. I just covered that up. So let's see here. The mean is 5.43, and the standard deviation is 0.054. Well, this, of course, this is going to be the sigma. Raise it up so you can read a little bit. So that's going to be your sigma there. So when you're looking to plug in stuff to formulas, well, that's going to be your mu. That's going to be your sigma. And then we go to what's actually being asked in the problem. What proportion of rainy days have a rainfall with pH below 5.0? Now, how I'm going to do the problem, and I'm going to do it with the normal tables. If you have one of those online calculators, you can just plug that in. But let's go ahead and do this. So I'm going to expand this, and we'll go here, and let's do the solution in blue. So solution. And I'll expand this text box here. My dock camera's at the office, and I'm not going to trudge and get it. So what you remember is that, first of all, we want to convert to the standard normal, which is our z. And you probably learned that the z in question, we are interested in the z value of 5.0 because what proportion of rainy days have pH below 5.0? So that's when we're interested in. So we want that. So that's going to be our x value. So we calculate, and the numerator will be a 5.0. And by the way, I should actually, well, 5.0. Well, using the formula z equals x minus mu divided by sigma. So z is equal to, our x is 5.0 minus 5.43 divided by 0.54. Now we can see this is going to be a little bit less than 1 standard deviation below the mean. That should mean something if you understand the thumb rules, but if you'd rather not, that's okay. So 5 minus 5.43, that's a negative 0.43 divided by 0.54, and I'm using my calculator, and it's a point minus 7963. So that's a value we look up, okay? Save that. So now we turn to our table here. And we're looking at 0.7963. And that's really close to minus 0.796, rounds to minus 0.8. So we look there. So if we go down here, hopefully you can see my cursor. This is minus 0.7. This is minus oh gosh, here. 7963. Down here, that's 0.21476, but it's really closer to minus 0.80. So what I'm going to do is I'm going to show you this. This is going to be the closest value here. And what we're looking for, remember, this is the closest thing right here. This minus 0.80. So I'll put this annotation here. Minus 0.80 is closest, is our closest entry. The other one, 0.79, is a little bit further away, so we're going to go with 0.21186. So returning to our problem, the closest z reading, the closest z value, give you a little time to catch up, is minus 0.80, and this gives us down here 0.21186. So that rounds to 0.2119 or something like that. So that's the table way of doing it. Now, the rest of the video, I want to give you a different way. So suppose we want to use an online calculator. And if you know how to do, if you know what this is with a numerical integral, you shouldn't be watching this video. But anyway, suppose we want to use an online calculator. So what we do here is we go to normal distribution. Yeah. Now, by the way, if you're in my class, you actually have a link to that. So let's see what we got here. This is a good one. And we know that well, it helps to have the thing here. So our mean is 5.43, and we have a 0.54 standard deviation. So we put those in. So let's go down here. 5.43. And our standard deviation. I better look this up again. I can't hold anything in my head. Uh, 5.54. So we put that in there. And we want everything below 5. That I can remember. Calculate. And we get 0.2129. That's very, very close. And you see what this does is this gives you the area under the curve. That's everything that's below 5 if your mean is 5.43 and this is your standard deviation. So that's a couple of ways of doing that problem. And thanks for watching.